Alright, let's read through this circle word problem. A router for a wireless network on a floor of an office building has a range of 45 feet. So the signal for this wireless router is going to travel 45 feet in every direction. The router is located at the point 30, 30. And you can see that in our diagram. Here is our router at 30, 30. The lettered points in the coordinate diagram represent computers in the office. So if you see on here, we've got A, B, C, D, E, F, G. Those are all computers on the floor of the office. Here's what they're asking us now. Find the equation of the circle which represents the router coverage and sketch this circle on the graph. And then the second question is, which computers will not be able to connect to the network through this particular router? That means they're out of range. So the first thing we want to focus on is, how do we find the equation of the circle that represents the router coverage? Alright, well that's actually should be pretty straightforward. We need to know two things in order to graph or find a circle. We need to know the center and the radius. So let's take a look. Let's find the center. Well, that is given to you. The center is at 30, 30. And that means we know that h is equal to 30 and k is equal to 30. There's our first part. Let's take a look at the next part. We got to figure out what the radius is. Well, if you take a look at this, if the range is 45 feet, that is our radius. That's how far the signal will travel in every direction. That's the distance from the center to the outside edge of the range of this router. So the radius is going to be equal to 45. Now we're going to need to change that to r squared for our equation. Let's do that now. That means r squared is 45 squared. Let's figure that out. 45 squared is equal to 2025. So r squared is 2025, and that's enough information to write the equation. So the first question, find the equation of the circle. Okay, the router, the equation for the router coverage. The equation for the router coverage is going to be x minus 30, there's our h value with the sign flipped, plus y minus 30, there's our k value with the sign flipped, and here is r squared, 2025. So there's our first question answered, the equation for the router coverage. Next question is, which computers will not be able to connect to the network? Well, it says we have to find the equation and sketch it on the graph. Let's sketch it on the graph. So here's our router, and we know we've got 45-foot range. Let's plot 45 feet. 10, 20, 30, 45. 10, 20, 30, 45. I can already see that C is not going to be in there. 10, 20, 30, 45, and 10, 20, 30, 40. We're going to go slightly off the graph. Let's just go ahead and estimate. Looks like there's 45. I want you to go ahead and sketch that circle. I'm going to go ahead and try to draw that circle. Do my best. See if I can get that to line up. Looks like I'm a little bit tall. That's pretty good. Let's do it right there. So sketch that circle, and when you do that, class, there's the range of our router. We can clearly see that the two computers that aren't within the range of that router are C and G. So our second part of our question, computers C and G will not connect. because they are out of range. C and G will not connect. All right. Sometimes on these word problems, you want to go back and reread it because it's common for students to answer the first part and draw the graph and then forget that the second question was, tell me which computers do not connect. All right. Let's take a look at the second part. Oh, so now it's asking us, what coordinate could the router be relocated to so that all computers in the office will be within its range? Is there a place we can move this router so that all the computers will be able to connect? And then plot this location on the graph and sketch the new covered circle. All right, so let's take a look at this. This might take a little guessing. I'm not able to reach C right now, so I can move up to get C. And I'm not able to reach G, but it looks to me like if I move one unit over here, I might be able to reach G. So let's go ahead and try a new router location right here. So I'm going to move from here to here. And let's plot that circle and see if I can get all of them. So I'm going to go ahead and count now 45 feet in all directions. 10, 20, 30, 40. Looks like I should be able to pick up C just barely here. 10, 20, 30, 40. We're going to go off the grid a little bit. There's about 45. 10, 20, 30, 40. We have no problem picking up the bottom computers. And then 10, 20, 30, 40, 45 is right here. Alright, let's go ahead and try to draw a circle that connects all of those together. Whoops, that is not a circle. Again, I'm going to try to be as close as I can, and I'll adjust it if I need to. Looks like we are getting, I'm a little bit big here. Let's try a little bit smaller. Whoops. Okay, that didn't work. Let's try it again. One more time. That's about the same size circle. Ay, ay, ay. Let's try one more time. A little bit tough when the controls don't work. Alright, and that looks pretty good. I can see that. It's a pretty good estimate of where the circle is. And now it looks like I've been able to move the router to where all of my computers are within the range. So for my question, it's asking what coordinates could the router be relocated to? And we can go ahead and write that. The router could be relocated to, and why don't you go ahead and just write that coordinate in. If you take a look at this, the coordinate for the new router location is at, it's at 10, 20, 30, 40, 10, 20, 30, 40. So it's at 40, 40. So I'm not going to write that. You can go ahead and write that for yourself. The router could be relocated to parentheses, and then you put in those parentheses 40, 40, and that will cover the entire office floor.